Namaskar, welcome to PK's classes. Today we are going to study about normal distribution. So if you see a frequency distribution curve, suppose this is a data where the frequency is in the y-axis and the variable is in the x-axis, and this is a histogram given, and from this histogram we found a bell-shaped curve. This is the bell-shaped curve we got. So this type of curves are called distribution curves, and there can be many such type of frequency distribution curve, or also called as distribution functions, and one of them is the normal distribution. And normal distribution is something where the data varies and the data is distributed around the mean. And if you plot a curve or graph between standard deviation and the probability density, then we can see 68.2% of the total data is within one standard deviation of mean. And there is a rule, we call it as 68, 95, 97.7 rule, where 95% of data lies within 2 standard deviation from the mean, and 99.7% of data lies within 3 standard deviations of the mean. So you can calculate the standard deviation and the probability density and the mean from a given data. For probability density, the function we can calculate it as using this formula, where x is the value of the variable, mean and mu is the mean of the distribution, and this is standard deviation. Mean is, or the average is the sum of each individual value divided by the total number of values. And standard deviation we can calculate in case of a sample. It will be, if the sample size is less than 30, then sum of each individual value minus the mean of the sample population divided by n minus 1. So sum of this square of the each individual value minus the mean of the sample population divided by n minus 1 whole square root. So this value is actually the variance, and the square root of variance is the standard deviation. And if it is a population data, then n we can directly take, and instead of the average x bar we have used mu here. So the standard deviation is a measure of the spread or dispersion of a set of values around the mean, as we have seen here. So this value is the mean, and the whole data lies from, say, this part to this part, and 99.7% lies within minus 3 standard deviation to plus 3 standard deviation. So normal distribution is that in which we get a bell-shaped probability distribution that is symmetric around the mean. We call it symmetric because the left and right side, suppose is say left side and this is right side. So right side is the mirror image of the left side, or left side is the mirror image of the right side. Then it follows 68, 95, 97.7 rule, as we have already discussed. About 68% of the data falls within one standard deviation from the mean, about 95% of data falls within two standard deviation from the mean, and about 99.7% falls within three standard deviation from the mean. And normal distribution, the data is defined by two parameters. One is the mean, because the mean, median and mode all are same for such data. So determines the mean determines the center of distribution, and standard deviation determines the spread or width of the distribution. So you can see here, so 99.7% of data lies within three standard deviation. So here you can see here, this is a flatter curve and this is a steeper curve. If the standard deviation is small, then we get a steeper curve. If standard deviation is large, we get a flatter curve. So application, the normal distribution is widely used in statistics because many real world variables tend to follow this pattern, and if it follows the normal distribution, then we can use the parametric tests. So average height of adult men in a certain population, say 70 inches, and with standard deviation of 3 inches, so it will be, the height will vary from 67 to 73 inches. So such type of data are called following normal distribution. But if it does not follow, then we call it as skewed distribution. That means that there is asymmetry of data, and it can be of two types: right skewed distribution and left skewed distribution. So right skewed distribution has a right tail, longer right tail, and left skewed distribution has a longer left tail. And in the skewed distribution, you will find that mode, median, mean all are different. So you can see, see here this is called positive skew, and this is called positive skew or right skew distribution, and this is called negative skew or left skew distribution. And you can see here in left skew distribution there is a long tail, and in the right skew distribution there is a long tail towards the right side. So the lump of data follows the tail in negative skew, lump of data at the start followed by a long tail in case of positive skew. And you can see here, in case of normal distribution, see, mean, median, mode all are same. All are same in case of normal distribution. If it is skewed, then median, mean, mode all are different. So if you see the difference between normal distribution and skewed distribution, symmetry, yes, in skewed distribution it is asymmetrical, whereas in normal it is symmetrical. Mirror image, left side is the mirror image of the right side. Bell-shaped curve in normal distribution, longer tail on one side. In skewed distribution, mean, median, mode all are equal. In normal distribution, mean is pulled towards the tail. You can see here, mean is pulled towards the tail in case of skewed distribution. Height, IQ scores are examples of normal distribution. Income, age at retirement are examples of skew distribution, income right skewed, and age at retirement left skewed, because very less number of people retire early. And statistical analysis, mean is preferred in case of normal distribution, because mean, median, mode all are same, and median is preferred over mean in case of skew distribution. And here we can use the parametric tests. We can apply parametric tests, and mean is the parameter, standard deviation is another parameter, and parametric test cannot be applied. Here we have to apply non-parametric tests. So this is all about the normal distribution. Thank you.